Okay, so a bit of a backstory on this particular video. Um, I'd say about 7 to 8 years ago, probably closer to 8 years ago, I bought my Kyosho RT6, and that was at a time, before the local tracks around me had switched to AstroTurf. We were all racing on hard-packed dirt, and so I bought several sets of rims and tires for that type of dirt, like hole shots and goosebumps and that kind of stuff. But as it turned out, I didn't end up being able to race the truck as much as I would have needed to wear through all of these sets of tires. So these tires, although they're brand new, they're actually like 7 years old. Okay, so they've just been sitting around waiting to be used. And once I got wind of the another vintage race in my area, namely the RC10 Talk vintage race, is going to be in Insanity RC in New Jersey. That track's a bit more like a sort of conventional dirt track where you'd use tires like Hole Shots and Double Ds and those kinds of things. I figured it would be nice if at some point I could bring my Kyosho XRT there and run these RT6 tires, because on my Pro-XRT rims, tires I have on that are primarily like electrons and octagons and tires that are meant for a more hard packed, smoother track. And truck tires are expensive, right? One pair of truck tires could be $25 to $30. So if I have perfectly good sets of tires, I'd like to be able to use them without having to spend more money on tires. So I figured it would be a nice experiment to figure out if I could do a RT6 style quick mount conversion for the Kyosho Pro-XRT. As it turns out, as you can see, the experiment was successful, and more than that, it's relatively straightforward. And also, you end up with the correct widths, right? A lot of times, if you do modern wheel conversions on vintage cars, the offsets are different, and so like the front width is too wide or too narrow or whatever. For this, it's actually like perfect. So I'm going to show you what I did. We'll start with the rear, because that's maybe the most straightforward. I'm going to just take this off. See, look at that, one hand. How nice. So this entire assembly here, from the dog bone all the way out to the wheel axle to the wheel hub here, that's all taken directly from a Kyosho RT6. You don't have to change anything. Well, you do have to change one thing. So the dog bone length is the appropriate size, but you do need to push it in a little bit to make sure that the diff out drive captures the end of the dog bone. Okay, and as luck would have it, the wheel axle is just long enough. It's actually the perfect length so that you can push it in and have it, the dog bone captured by the diff out drive, and also have the wheel hub, the hex here, in the perfect location for the wheel. So all you have to do is on the inside of this wheel axle, before you mount it through this hub carrier, is to put a 4mm axle spacer on there, and that'll push this whole thing in by 4mm. What I did is I just used a 5x10mm ball bearing, because those are 4mm wide, and it just pushes the whole thing in. And as you see with that 4mm offset, this runs right up to the outside bearing on the rear hub carrier, and it fits perfectly. So that works fine. And again, when you mount the wheel, what you're looking for on both the front and the rear on this truck is for the inside of the rim to line up with the hinge pin that mounts to either of, in this case, the rear hub carrier, or in the case of the front, the caster block. Okay, and I'll show you on the front later that also lines up. So that's all you have to do here. And I should say one more thing, and this is perhaps optional, but I would recommend it, is you might want to shave this material here a little bit on the suspension arm, just to give a bit more clearance between this dog bone pin and the suspension arm, because as you can see, the pin extends a little bit beyond the actual dog bone itself. Now you could shave the pin down to get more clearance, but if you do that and the pin shifts, then it might not be captured correctly by the dog bone, and then the CVA kind of falls apart. So my preferred solution is to just shave a little bit of the arm material away itself. Just get a Dremel with a round sanding bit, and just start shaving away just a little bit, maybe a millimeter or two. And that'll give you enough clearance so that this will move freely without the suspension arm interfering with this. And by the way, this is not exactly a new trick. The MIP CVDs that were actually made for this truck had that exact description in the instruction manual, because the CVDs have a larger, or sort of a fatter joint here, just like the CVAs is a fatter joint than the actual stock universal. This joint isn't quite as wide, and so you get better clearance to the arm. This part here is wider, so you have to do that little bit of shaving. Okay, but that's, really no big deal. Mounts right on there, no problem. Now, getting to the front, I'd actually tried a few different things, and in the end, I landed on what I realized what worked the best was actually the simplest, and I was kind of kicking myself over it. So I'll just get straight to the point here. So I take this off. And by the way, getting to the front, talking about the offsets, inside of the wheel lines up with the hinge pin here. Great. So you don't need to change the caster block or anything like that. All you got to do is just take your RT6 or an RB6 steering knuckle and make sure you have the wheel axle and quick mount hub here mounted onto this, and you just plop it right in with a small modification. And what you do is the height of this steering knuckle is a little bit smaller than the gap provided by the stock caster block, the Pro-XRT caster block. But otherwise, it's a perfect fit. So all you need to do is get some flanged bushings. So in my case, I used Kyosho TF008. This has some kingpin balls and some flanged bushings, some other parts. So I just had a few of those lying around. And that basically allows you to take a 4mm hole, which is the hole that would normally go through this caster block, and it sizes it down to a 3mm hole. So that way you can use this 3mm hinge pin to go through this steering knuckle, because the hole that you would use to mount the steering knuckle is sized for a 3mm hinge pin. But the way that the stock steering knuckle mounts, the Pro-XRT steering knuckle mounts onto this, uses a 4mm hinge pin, and obviously that won't fit here. Now you could try to drill this 3mm hole to 4mm to make it fit, but then you're losing material on the outside that would make it more fragile. Simpler approach is to get some flanged bushings here, and it just almost perfectly fills up the space there. Okay, so that works great. And this hinge pin here is, I have an extra hinge pins of this that come from this part of the arm here. This hinge pin here that mounts the caster block, you just take another one of those and plop it right in here. It's a perfect fit. Okay, that's all you got to do. Now, when you do this, the steering geometry will change a little bit, and in two ways. The first thing is you will get some trailing axle steering geometry. The stock unit, the hinge pin goes straight through the wheel axle. So this is an inline arrangement for the steering knuckle. For this, the wheel axle is here, but the hinge pin is up here. So the steering axis is offset from the wheel axle. And when you look at that vertically like this, that's called a trailing axle geometry. So what that's going to do is generally calm down the steering a little bit. And the other thing that happens is you'll notice that the hole here and the hole here that mount, that the hinge pin mounts through to mount this steering knuckle for the stock unit is offset. It's not perfectly vertical, okay? And the reason for that is because this steering assembly was originally designed with what's called an inclined steering axis. And what that does is, I think it pushes this in. Is this the right one or the left one? This is the left one. Okay, so that would be on this side. That's going to push this out like that. And then to make up for that, you take the whole thing and you run a bit of camber, and that pulls it in. So the steering axis is going to be going this way instead of perfectly vertical. And what that does is, if you take that line and you extrapolate that along with a line, I think that corresponds to the center of the tire, you get an intersect point with a smaller space than if you had two parallel vertical lines. And that results in what's called a reduced scrub radius. And with the scrub radius is smaller, that means that the distance the wheel is traveling as you're turning the steering knuckle around that center point, that steering axis, is smaller, and so there's less scrub. When there's less scrub, that means there's less effort required to steer the wheels, and it also ultimately means that the wheels will also naturally return to center more readily. Now, why did Kyosho design it that way for the Pro X and the Pro-XRT compared to everybody else that doesn't have an offset or a steering axis inclination? I don't know. If I had to guess, it may have been related, in some way related to the fact that older steering servos from the early 1990s weren't as powerful as modern servos. So maybe just to get a little bit faster steering response, you would have an inclined steering axis. So maybe they were looking for that. Maybe they wanted also a steering geometry that naturally had better return to center. Again, assuming maybe the steering servo was weaker, or if he had a servo saver in there that was causing some slop, this inclined steering axis would allow the wheels to return to center more easily on corner exit. So there's maybe something related to that. Now, you can, if you think about what that means for the scrub radius, and then you go back to what happens when you look top down at the trailing axle geometry. Well, you have your steering axis here, okay, and then you have this axle being pulled back. You could argue that a trailing axle geometry also gives you a larger scrub radius along this plane here. So basically, by going to this RT6 setup with a trailing axle this way, and with a vertical axis this way, you're probably getting a larger overall scrub radius, which means it will require more effort to turn the wheels. But modern servos are so torquey and powerful, it doesn't matter. So yes, change geometry, but I wouldn't worry about it. I drove this around with, not with these new tires, but with these sort of practice tires here, and it handles perfectly fine. So very simple modification to convert this to RT6 style rims with quick mount and everything. So yeah, I hope that's you found that interesting and informative. And yeah, that's it for now. Thanks for watching.